Hello friends, today we are going to discuss our topic imperfections in solids. Now the first question is, what are the defects? Defects are basically the deviations or irregularities in the arrangement of constituent particles. While arranging the constituent particles like atoms, ions or molecules, some deviations or some irregularities occur, which are known as defects. Basically there are two kinds of defects, point defect and line defect. Point defects occur when there is a deviation around an atom, while line defects occur when there is a deviation or irregularities in entire rows of lattice points. Basically today we will discuss point defects. First defect is stoichiometric defects. Now what is stoichiometric defect? It is an point defect that do not disturb the stoichiometry of solid. What is stoichiometry? Stoichiometry means the relationship between the products and the reactants is not disturbed. This defect is also known as intrinsic or thermodynamic defect. In this defect, ratio of constituent particle is maintained, like this. Na plus and Cl minus, the ratio of both the particle is maintained. Electrical neutrality is also maintained. Now, stoichiometrics defect is divided into two parts for non-ionic solids: vacancy defect and interstitial defect. In vacancy defect, some constituent particles are missing. This effect can also be created by heating. Like if we heat a substance, then the constituent particles get the kinetic energy and they leave their original positions. So in this way, some constituent particles are missing in vacancy defect. And when some constituent particles are missing, then the density of substance decreases. In interstitial defect, constituent particles are moved in interstitial sites. Now what are interstitial sites? Interstitial sites are some empty spaces in which small constituent particles like cation move in interstitial site and the density of substance increases. For ionic solids, first defect is Frankel or dislocation defect. This defect arises only when there is a large difference between size of cation and the size of anion. In this defect, small sized cations leave their original position, and in this way vacancy defect is created. And these same small sized cations which leave their original positions goes into interstitial site, and in this way interstitial defect is created. It means vacancy and interstitial, both the defects are created in dislocation defect. Density remains same. This defect arises in solid having low coordination number. Examples are silver chloride, zinc sulfide, and silver bromide. Next is Schottky defect. This defect arises only when the size of cation and anion is comparable. Equal number of cations and anions are missing in this defect, and in this way vacancy defect is created in Schottky defect, as equal number of cations and anions are missing, so the density of the substance decreases. This defect arises in solid having high coordination number. Examples are sodium chloride, potassium chloride, and silver bromide. Silver bromide is the example of both the defects. Our next defect is impurity defect. In impurity defect, some kind of impurity is added. Like here, strontium chloride is an impurity which is added to molten NaCl. When SrCl2 is added in molten NaCl, then Sr2 plus replaces two atoms of Na but occupies only one position. Let's see this diagram. In this diagram, this is the crystal of sodium chloride. Sodium has one valency, whereas Sr has two valency. So this Sr replaces two atoms of Na. As Sr2 plus has two valency, so it replaces two atoms of Na, but it occupies only one position. So one cationic vacancy is left, as it occupies two atoms of Na. First atom is this and second atom is this, but it occupies only one position. So the second position is left, and this is known as cationic vacancy. If molten NaCl containing SrCl2 is crystallized, Sr2 plus replaces 2 Na plus but occupies only one position, and the number of cationic vacancy produced is equal to number of Sr2 plus added. Next is non-stoichiometric defect. This is the point defect in which ratio of constant particles is not maintained, but the electrical neutrality is maintained. Under this, first of all, we will discuss about metal excess defect. This defect is created due to anion vacancies. In this defect, the number of cations are greater than the number of anions. For example, if we heat the crystal of sodium chloride in the presence of any vapors, if we heat the crystal of sodium chloride in the presence of the vapors of sodium, then the sodium atoms which are present in the form of vapors loses its electron. Then the Na which is present in the form of vapors loses its electron and reacts with chlorine to form NaCl. And the vacancy which is created here is occupied by the electron. And in this way, the ratio, if we see the ratio, then the atoms of Na are greater than the atoms of chlorine. Here if we see, there are 4 atoms of sodium, but there are only 3 atoms of chlorine. So the ratio of cation is greater than the ratio of anion. Na vapors, the sodium atom which was present in the form of vapor loses its electron and it reacts with the chlorine, and it reacts with the chlorine present in crystal, and the vacancy which was created is occupied by the electron. So this unpaired electron which is present at the place of anion vacancy are also known as Farbaughn center or colored centers. When these electrons are excited, they impart color. That's why when pure NaCl, which is white in color, is heated in the presence of vapors of sodium, then it converts into yellow color. In the same way, when lithium chloride is heated in the presence of Li vapors, it converts into pink color. And when potassium chloride is heated in the presence of vapors of potassium, it converts into purple color. This metal defect is also created due to the presence of extra cation at interstitial site. For example, if we heat the crystal of zinc oxide, then the ion of zinc is formed and oxygen and 2 electrons are produced. So this ion of zinc settles into the interstitial site, and in this way the cations increases, and in this way the metal excess defect is also created. Next is our metal deficiency defect. This defect is created due to the variable valency of metal. Like iron has 2 valencies, Fe2 plus and Fe3 plus. When 2 atoms of Fe3 plus replaces 3 atoms of Fe2 plus, then the cationic vacancy is created. And this cationic vacancy led to the metal deficiency defect.